Tell me. I accordingly talk, right? Because I will speak for many hours on this topic, but the minimum time which is required to cover this topic is at least minimum is 2, but I will do justice for 90 minutes is okay? 6 o'clock?
Yeah.
That's a
It's gonna very key, that's wrong.
Before you start recording, I will speak on officially, don't record, right? Then once I start formally, then you start. Enough memory space is there, then only you can record.
Yeah.
Otherwise, for 90 minutes it is there. Okay. Alright, before he starts now, I will speak to you informally. Can I know your background? You are from which branches?
So shall I give you the introduction before that?
No, you will give, but I am just asking
I'm-
informally. So
I'm
that I will
from
start.
that.
We are from mechatronics.
Electronics,
Yeah.
all
We-
4 guys.
We follow mechatronics engineering.
Mechatronics, okay.
We are in the final year, last semester. Electronics.
Okay. What about you?
Yeah, that's that. Yeah, that's fine. I was that first year. So we are about electronics engineering and
So signal processing you understand?
Yeah.
Mathematics and signal processing you understand? That's the prerequisite for this course, for this topic. Right? Some signal processing is involved. Okay? Anyway, I will.
You have to open.
Okay. Minimum time I planned it for 2 hours actually, right? But okay, I will try to. But if I can stand here, I can use this also. Is it coming? No. But no way, no problem, I can use it.
You can use this.
No, pointer, this is not coming. All right, so, okay.
Give me a few, one
Yeah,
minute.
after that you can start.
Good evening, ladies and gentlemen. This is Professor R. Sinha. He has been appointed as a visiting professor of the SLTC. And he's actually currently a professor of the IIIT Bangalore and IT Myanmar. Specialized in electronics and computer engineering disciplines. His main research interests are medical image processing, medical image analysis, cognitive ability of human brains, cognitive ability of human brain, and outcome-based learning. Those are the main research interests and the work that is involved. Today you guys will have a lecture also, medical image analysis. He has published so many journal articles and many books, and concluding all this knowledge and findings, please make kind attention on this current lecture, and if you have any kind of questions, please make clarify during or after the lecture. And thank you. And Professor, please proceed.
Okay. Thank you so much, Professor, again for
Yes.
giving introduction. This third time today, getting introduced again and again. Nah?
Yeah.
Because this third lecture, I am talking. I have already done 4 hours today. More than 4 hours rather. I was discussing again outside the lecture hall. Okay. I did two different lectures this morning and afternoon. So I am happy that you guys have come here to understand and to know about some basics of medical image processing. The topic is very broad, that is medical image processing, right? And when we talk about medical image processing, we think that it involves the knowledge of lot of medical science, which is not true. If you decompose this topic, right, synthesize this topic, you will find, signal processing. What is signal processing? Signal is processed for some purpose. Now signal may be anything. Is it clear? Signal may be anything. Signal may be speech, you will call it as speech signal processing. Signal may be image, you will call it as image processing. Signal may be digital image, you will call it as digital image processing. The signal, now when we talk about image, there are different types of images. Images may be satellite images, images may be remote sensing images, images may be fingerprints, images may be medical images, X-rays, CTs, MRIs, PT, right? So many medical images are there. So in the signal processing, if the image or if the signal is medical image, it becomes medical image processing. That's all. It's very simple. So what I will be focusing about, I will be talking about image processing and CAD. CAD is computer aided diagnosis, right? Nowadays, doctors, and we are happy that we have one doctor with us as a participant, right? So doctors are also using CAD based system. Last year, one of PhD scholar got awarded PhD degree from Technical University, and his topic was early detection of breast cancer, where we involved one doctor also. He always used to give us opinion. See, we engineers and computer science people are doing some research, but what is the guarantee that we are doing or we are moving in the right direction? They only can authenticate, that is the doctors and the physicians. And therefore, in that study, we included one senior radiologist from Cancer Research Center who could, validate our result that we are getting better result. Okay, so that is about CAD, that is computer aided diagnosis system. All right, and then next I'll give some case study of breast cancer detection just to demonstrate how does medical image processing work, how this can be used for different applications. And I want to tell you, students, very interesting area. You have to get into, you will get good quality of projects, you will get good quality of publications. And actually, today morning and afternoon I was talking, I want to tell you, if you do some research which is using image processing, there is always more possibility of getting published. The possibility of publication becomes better and enhanced when you use some image processing, right? You will feel when you start publishing. Then I will talk about health informatics as a concluding remark. What is health informatics and how health informatics can use or using image processing. So I'll start with image processing, that is medical image processing in CAD. This slide is very important for you as a beginners, right? As I told you, I'll speak very basics about, then only you will understand how does medical image processing help us in the real time applications. We need to understand what the digital image is. See that digital image, you all understand picture. When you take a photograph, when you print it, that becomes analog signal. All engineering science guys, we understand analog signal and digital. Analog is continuous. All natural signals are analog. What is digital? The moment you store anything in the computer, any image in the computer, it becomes digital, right? And now what is the phenomenon? If you click to the computer, suppose you store your image with certain name in the computer, you put a cursor, you must have seen that it tells you 1025 or 10, something like that, some 256 cross 256. What is this? It tells you there is a photograph which you have captured, how many pixels are required to store that image inside the computer. So when it writes 256 cross 256, it tells you that in X direction there are 256 pixels and in Y direction there are 256 pixels. And I tell you, the entire research work on image signal processing that applies on pixels only. Now we need to understand what is pixel. Everyone knows pixel, but we write pixel. How do we write? P-I-X-E-L. But actually that's not a dictionary word. It is picture element. But in short, how do you write? Pixel, picture element. That is picture. So what is picture element? Smallest element of picture is called as pixel. Now we need to understand how image is formed. Therefore, I have included this diagram. How do you see me? How can you see me? What is the phenomenon? The phenomenon is there is a light source. If I go outside, the natural light source is sunlight. Here is this is light source. What is the concept? How do you see that this object is black and this object is black? I'll tell you. This light is coming incident on my body. What happens whenever something is incident on the body? This is the object. See the diagram. Something is incident. What will happen? The object will reflect some component and some component will be absorbed. If it can absorb all the component of light, it's black. But because it does not reflect anything, it completely reflects no absorption, white color in between all different colors. So how can you see me? Because my body is reflecting some part of light and therefore you are able to see me. Otherwise, if my body doesn't reflect any component, you will not be able to see. That's a very simple phenomenon. Now when you store inside the computer, what happens? Some component is getting reflected. How much is the intensity? How much is the brightness? That brightness value is stored inside the computer. So when you write 256 cross 256, I'll give one more example. Suppose there is a site 1024 cross 1024. In the digital age, 1024 we call it as 1 kilo. Do you understand? 1024. So 1024, 1 kilo into 1 kilo is 1 mega. Do you understand? 1 mega. Now, you are storing something in the computer.